Hello, YouTubers. Well, I wanted to talk about 3D printing on solar, as you could see in the title. Now, I live in an RV, as many of my regular viewers know. I've been living in the RV for just over 3.5 years now. In October, it'll be 4 years. And I spend about 7 months of the year completely off-grid out here in the Southwest desert. And off and on, I'll plug in when I'm in RV parks, or like now I'm at a friend's property, Jeannie and Tony's place here in near Kingman, Arizona. And the RV is plugged in. But most of the time I'm off-grid, and I have a fairly modest solar setup. I have on the roof 2 100-watt Renogy solar panels, so 200 watts total, which a lot of people, when I first set up the RV, said, oh, that's not near enough. Well, I don't use power the way most people do. I mostly run things directly off the solar battery. I only turn my inverter on rarely for power tools or test gear, but everything else runs pretty much direct off the solar, so it's very efficient. And I've never had a want for power. Even on cloudy days, I can still reach a full charge. I might have to be a little conservative on my usage, but I can still reach a full charge. But can I 3D print on solar? I always assumed not, because 3D printers, they use a lot of power. They've got this bed heater that has to heat the bed surface up to 60 degrees Celsius and keep it there. And they've got a nozzle heater that has to heat the nozzle up to 195 to 210 Celsius, depending upon the material you're printing, and keep it there. And those heaters draw a lot of power. And so I always presumed I wouldn't be able to print on solar, and every time I want to 3D print, I run my generator, which has limited my 3D printing because, you know, it's got to use fuel, and it's kind of annoying having the loud sound because the sound of the generator resonates inside of here. But, you know, I was thinking about it, and I decided to do a test. Can I print on solar? So I got my kilowatt out, and I put it in line with the 3D printer, and I did some measurements. And I saw a low of about 55 watts of usage, and a high draw of about 288 watts of usage when the printer was, you know, the heaters were on and everything's running. And so I thought, yeah, that's pretty much what I thought, that I wouldn't be able to do that, because I can get about 185 watts out of the panels on a bright sunny day with direct overhead sun. And the printer is going to draw 288 watts, and so it's not going to work. And that's why I always ran the generator. I didn't think about it. I had a facepalm moment the other day because I realized the 3D printer really only draws 288 watts when both heaters are on, everything's on. But that's only during the initial warm-up. Once the bed reaches temperature, that heater begins pulsing occasionally just to maintain the temperature. And the same thing with the nozzle heater. It pulses just to maintain temperature. And in reality, once the printer's heated up, that duty cycle on those heaters is much, much lower, like somewhere down around 20 to 30%, if even that. So overall, its power usage is way down on the low scale when you average it out, rather than at that peak. And so, let's do a test. Let's try to 3D print on solar. Now, I do have a 100 amp hour, what's it called? Ampertime lithium iron phosphate battery. And that's plenty of reserve capacity. So let's see what happens. Let's 3D print on solar and see how it goes. Okay, the printer is on. It's idle. And we are drawing 7.8 watts current. There we go. 130 milliamps. At 120 volts while it is idle. Now I am going to hit print, and I want to print the case top for my little transmitter. And now the bed heater has just turned on, so it's heating the bed. And if we go over here and we look at the kilowatt, we'll see that now we are drawing, am I on current? Yeah, 2 amps on the AC side, which would be 20 amps on the DC side, which is around 170 watts or so. In fact, let's find out. 147 watts just for the bed heater. It hasn't even turned on the hot end heater yet. Once that turns on, we'll be at full draw, and we'll see what it looks like. Okay, the bed's almost up to temperature, and the hot end heater just turned on, so it's heating. So both heaters are on at the same time, and now we're at our maximum current draw, and we're hitting 192 watts, which is 2.63 amps, 2.64 amps at 120 volts. So 26 amps or so on 12. But that number is going to drop pretty soon because the bed's just reached, there it goes. Did you see that happen? The bed has reached its temperature now, so the bed heater is going to start pulsing. There, it dropped off again. 130 watts, 132, 131, 43, 11, 8, 9. Both of the heaters must have cycled there. Yep. So when both heaters turn off, we're dropping back to 8 or 9 watts, jumping up to 100 and some, 110. So you can see it's bouncing around a lot. And that's because those heaters are not staying on all the time. So our actual average power consumption is going to be well below 100 watts. My solar setup should be able to handle it just fine. So we're going to let this start its print job, and we'll go back over and look at the charge controller's output, and we'll see what it's showing. But you can see here, look at that, that's wattage. So we're seeing those high spikes, but we're spending a lot of time in the low numbers. So I should have no problem at all doing this entire print on my solar. Let's go look at the panels outputs. Okay, so we're back here looking at the monitor for the panels. And yeah, okay, so the battery's at 13.6 volts, so we've pulled it back a little bit. And the PV voltage, the panel voltage, is matching that, which means that we're drawing the maximum that the panels are giving me right now. Now it's still a little after 10 a.m., so we're not at midday sun yet. We're getting 127 watts continuous out of the panels. That's 9.45 amps at the 13.5 volts. So 127 watts. That exceeds what the printer is drawing at the low end by quite a bit. And we're staying stable at 13.6 volts. So I'm going to let this print run for about an hour or so, and we'll come back and we'll see how things are holding up. Well, the print is nearly finished. Let's take a look and see what we are doing as far as power usage. The voltage on the panels is 15.8 and the battery's at 13.9, so the battery's showing fully charged and we've got surplus power. We're not even drawing all the power the panels are producing. They're sitting at 121 watts. Current 7.7 amps. It's varying a little bit, but remember those power spikes are coming and going from the heaters turning on and off, so this is more like an average. But the battery's fully charged. We got a surplus, so right now the printer is running completely off the solar panels and we're not even touching the batteries, so it's easily keeping up. I'm impressed and quite happy. And just in case you were wondering what it was I was printing, it was this. It's the top lid for this case for the Zactec CW Flea QRPP transmitter that I'm co-developing with Zactec. So this is the case. The lid goes on here and it should snap fit in just perfectly if I got my clearances right. Oh yeah. Clicked right in. Perfect. Yep. Alright, well there we go. Looks good. Key hole for the plugging in your key. Antenna, receiver, USB port, 12 volt power, band indicator LEDs, band selection, tuning down, tuning up. I'm going to reprint with that with a recess for the logo. I goofed up and printed this with a brim and it filled in my recess with a brim for some reason. Cura sometimes isn't very smart. I figure a brim would just be around the outside of the model, not the middle. Alright, well anyway, that's what I was printing. And as you can see, came out just fine. Hour and 57 minutes 3D printed on solar power. That's right, printed entirely on sunlight. It's so cool. Well, I'm quite happy with the result. So, my little solar setup, which is only 200 watts of panels, not a lot, and my 100 amp hour battery, which was not even really touched, is adequate to run my Anycubic i3 Mega. That was a 1 hour and 57 minute print. And as you saw, the battery was still showing fully charged there towards the end of the print. So it was running completely off sunlight. That's just kind of cool. Yeah, so I would say if you got a 3D printer and you're thinking about printing off solar, it's definitely doable without a whole lot of solar input, you know. So if you have a marginal, nominal solar system set up, I've only got 200 watts. I'm at the low end of the scale and I can do it. So there you go. It works. I can print off of solar when I'm off grid. I don't know why I didn't try this 3 years ago. Oh well. I hope you found that useful and interesting, and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.